All right, so financial models. So we're going to be learning to identify the variables in an interest formula, use the compound interest formula to solve problems, and use the continuous interest formula to solve problems. So there's two separate formulas for that. And then we're going to use logarithms or logs to solve for time. Okay, so that's why it's in this section or this chapter. We're going to use logarithms to solve these exponential problems here. So when we're dealing with a financial math situation, we have a principal, which is the initial or beginning amount of money. Okay, so initial or beginning amount of money. The interest rate, it's always going to be written as a decimal. So they're going to give you that interest rate as a percent. We want to convert that into a decimal. So we're moving the decimal place 2 places to the left from the percent to get that in decimals. Like 6% is 0.06. So be careful of that. That's a pretty common thing. We just get in a hurry and forget to do that. Time is how long your investment is in that account. It's almost always in years. Okay, and so when we're dealing with these accounts, if they told us 6 months, we want to express that in years. That'd be 0.5 years. Okay, so time is always going to be in years. Simple interest is interest paid only on the principal. Okay, so they only pay interest on the principal investment. They don't pay interest on anything you gain after that. Compound interest is when you pay interest on the principal plus the accumulated interest. Okay, so compound interest, that's how your savings accounts at any of the banks in town here, if you have a savings account, it's compound interest out of that. So that's the most common way a bank is going to do that. If you're dealing with a credit card, it's also compound interest. If you have an account or a balance in your account at the end of the month that you don't pay off, then that becomes your principal, and then they charge you interest on that principal, and they compound. I think it's with credit cards, it's usually compounded monthly with them. So savings accounts in town, they vary depending on what account you have there. But compound interest is they pay you interest is given on the principal plus the accumulated interest. All right, so here is our compound interest formula. A equals P parentheses 1 plus R over N, and then that parentheses is raised to the NT power. Okay, the A is the account worth. Okay, so that's how much the account is worth after a given amount of time. The P is the principal. The annual interest rate as a decimal. So just reminding us of that. N is the number of times compounded per year. Okay. So if it's monthly, that's going to be 12 times. Quarterly would be 4 times. We'll talk about some of those things as we get into the problems. But N is going to be how many times it's compounded in a year. T is going to be time in years. Okay, so account worth, that's how much we're going to get at the end. That's how much the account has got in it. That's after the interest has been added in. Principal, that's how much we started with. Our interest rate, remember, change that to a decimal from the percentage. The N is the number of times you're compounding in a year. Okay, so compound interest, they're going to say in the problem something like compounded monthly, compounded quarterly, that sort of thing. Okay, so some common values for N are going to be like annually would be N equals 1. That's 1 time per year. Semi-annually would be 2 times a year. Quarterly in would be 4 times a year. Quarterly is probably the most common for a regular savings account up here. If you go to CBNS or Hardin County Bank or anything like that, you open a savings account, they're going to compound interest quarterly. So that means at the end of March, you get interest added back to your account. And then 3 months later, at the end of June, you get the interest added to your account. And they do that 4 times a year. Okay? And it's based on what your account has in it. Throughout that 3 month period. Monthly, we said that earlier, that would be 12 times in a year. And then daily would be 365 times in a year. You do find some monthly accounts, this day and age with the internet banking and all that stuff, you can bank with pretty much any bank in the world out of that. And some of the larger banks offer a monthly interest compounding. Daily is very, very rare. You're not going to see that too often out of that. So that would be more like maybe a money market account or something like that, where you've got it with an investment firm and they guarantee you 3% daily or something like that. That's going to be a rare thing that you're going to see that. But most common ones are quarterly or monthly as far as our everyday lives. How do they go? All right, so let's get an example here. So here we have, you're investing $5,000 at an annual rate of 3.5% compounded quarterly. So when you see those words, compounded quarterly, that's what tells me that I'm going to use the compound interest formula. So I'm going to use that formula, A equals P 1 plus R over N to the NT. That's the formula that I'm going to fill in the stuff for, okay? So it says, how much money will you have if you leave that $5,000 in there for 10 years and you don't add anything to it and you don't take anything out of it? So you're just taking your $5,000 and you're putting it in this account that's drawing 3.5% quarterly. What are you going to have at the end of 10 years? Okay, so our principal investment in this case would be how much? 5,000. What is our interest rate as a decimal? So we're going to move that decimal twice to the left. So that's going to be 0.035. If we're compounding quarterly, what is N? 4. And then we're leaving it there for 10 years. So what we're going to do is we're going to plug all those things into our formula. Four times 10. Okay. Now the good thing on this problem is it's just a straight type that into the calculator exactly how it's written, and you're going to get what the account is worth. After 10 years, we're going to find out how much money we got. So we're taking that formula, 5,000, parentheses, 1 plus the interest rate, 0.035, divided by 4, and then close the parentheses, raised to the 4 times 10. If you wanted to type 40 there, you can. So at the end of the 10 years, we're going to have $7,084.54. On these problems, unless they say round to the nearest dollar, you're going to round to the nearest cent, because we're dealing with money. 2 decimal places on these problems, unless they say round to the nearest whole dollar, which they will do sometimes, but most of the time we're going to round to the nearest cent. That's what's going to go into our account. Now, here's what happens with the bank. This 0.00419 there, they don't give that to you. They keep that. It's kind of, and if you do that for every account you have, that adds up to just some profit for the bank. That's what happens out of that. So you don't get that extra money added. It's kind of a little bit shady, but that's really what's going on there. So pretty neat thing that you just see how the world works there. All right, so let's try another one here. So we got $20,000. You want to have $20,000 in 8 years. Okay, the account you put your money in pays 4.2% compounded monthly. How much do you need to deposit today so that in 8 years you will have $20,000? Okay, so in this case, we have the account worth, we have the interest rate, we have the how many times it's compounded, and we're waiting 8 years. So we are using the compound interest formula because it said compounded monthly. That's what tells us to use this formula. Okay. So in this case, we're looking for the principal. That's the part we don't know. We know 20,000 goes over here. Over here we've got 0.042 divided by 12 to the 12 times 8. So in this case, how are we going to solve for the principal amount? What is this thing over here? What is that? Is it a variable or is it a number? All of this stuff I highlighted. What is that? Is that a variable or a number? Number. It's just a number, okay? So our variable is P times that number. So all we got to do is divide by that ugly number right there to get that to work out. So we're going to divide by the 1 plus 0.042, over 12 to the 12 times 8 is 96. So we're dividing by that 1. So I'm going to put 20,000 divided by, and then I'm going to put parentheses, and I'm going to do a double set of parentheses there. Because I need that 96 to be in the parentheses for the bottom. Okay. You could also put that in as a fraction if you wanted to do it that way, and your calculator will convert it to a decimal. If it helps you to visualize that a little bit better. Same number there, okay? So in order to have $20,000 after 8 years, we need to invest $14,300 and how many cents? That's right, everybody that's trying to answer. 85 cents. Round it up. If you rounded down there, you wouldn't get to the $20,000. You'd be stuck at like $19,999 and probably 2 cents or something like that. You'd be a little bit short. Okay. So here we've solved for the principal that we need in order to have a certain amount once we reach a given amount of time. Now, the next little type of problem is a continuous interest problem. So continuous compound interest. This is best case scenario for interest. That means you're constantly getting interest put back into your account. It is all the time happening. It doesn't wait till the end of the 3rd month and the end of the 6th month and end of the 9th month. It does it instantaneously. Okay. So what we have here is what I call the PERT formula. The future value or the account worth. P is still the principal. That's what we put into the account. Now we got this base E. We've seen that in the chapter already. That's E to the RT. So E is that natural base. Remember, E is something like 2.71 and some decimals after that. It's a number. It's like pi, okay? R is your interest rate, T is time in years. Same stuff. You're going to see the word continuously in the problem. Okay? If it's compound interest like the other formula, you're going to see compounded monthly, quarterly, daily, something like that. If it's a continuous interest problem, you're going to see the words continuously or continuous interest. Something with the word continuous in there. That's how you're going to know that that's the formula you're going to use. Okay. So let's look at an example of that. So here we're investing $5,000 compounded at 3.5% compounded continuously. So that's how I know to use the PERT formula. A equals P times E to the RT. Okay, that's how I know to use that formula. They want to know with continuous interest, how much will you have after 10 years? Okay. So our principal here is 5,000. Our rate is 3.5%, so that's 0.035. Our time is 10 years. Okay, so we're going to plug that in. That's going to get us the future value or the account worth after that. So we're going to put in 5,000. To get the E, you hit second natural log. 0.035 times 10. So $7,095.34. So comparing that to what we did on the first example. So the first example we did had $5,000, 3.5% compounded quarterly. We gained about $11 with continuous interest on the $5,000 that we invested. $11 doesn't seem like much, but over time, in 10 years we gained $11. In 20 years we're going to gain not $22, but more than that. Compound interest adds up quickly. The bigger our investment is, the more we're going to gain out of that. So continuous interest grows a little bit faster because your interest is being put back into the account more often out of that. So this is more than we got with compound interest. Okay. All right. Now let's take that idea and let's solve for an exponent. Okay. So here we have, we're going to use logarithms to do that because to solve an exponential, you're going to use logarithms. Okay. So in this scenario, we have how long will it take for $10,000 to double if it's invested at 5% compounded continuously? Compounded continuously tells me that I'm going to use the PERT formula. So knowing which formula to use is key. Okay, because it said continuously, that's how I know to use the PERT formula. So my principal amount is 10,000. If I'm going to double that, what's my account worth going to be? What? 20,000, yeah. And then my interest rate, they said, was 5%, so 0.05. So I'm going to plug all that stuff into my problem here. So I got 20,000, 10,000, e to the 0.05 t. We're trying to solve for t. We want to find out what t is there. So we've got to get the exponential part isolated first. So I'm going to get rid of that 10,000 by dividing by 10,000. So that's going to be 2 equals e to the 0.05 t. Now, how do I solve that equation? I want to get rid of the exponential. So the base of the exponential is what? E. So what logarithm gets rid of a base E? Natural log. So I'm going to take the natural log of both sides. Natural log of 2, natural log of E to the 0.05t. On the right-hand side, that natural log of E cancels out. And so all I'm left with is a natural log of 2 equals 0.05t. And we're one step away from finding out what t is here, because all we have to do is divide by the 0.05. And that's going to get us how much time in years I need to leave my money there to double it. So natural log of 2, close the parentheses, divided by 0.05. I need to leave it there 13. I'm going to round to, does it say? Generally, let's go 2 decimal places there, because we've been doing 2 decimal places with the money. So let's go 13.86 years. 13.86 years. That's if I don't put any more money in there. So I just put that $10,000 and I just set it aside and I left it there for 10 years and didn't do anything else. It will double in 13.86 years. About. Okay. Here's the neat thing though. If I invested $1 million in this same account, in 13.86 years, I'll have $2 million. It doesn't matter what your principal investment is. If you're doubling it, it's going to take the same amount of time to double whatever money you put in there. So if you put $1,000 in there in 13.86 years, you're going to have $2,000. If you put $1 million in there in 13.86 years, you're going to have $2 million. It doesn't matter what your investment is. The time is the same to double it. If they said triple it, the time, you look at $30,000. It takes the same amount of time to triple 10,000 as it does to triple $1. So time, if nothing else changes. All right, so let's look at this problem. So we want, how long will it take $8,000 to grow to $10,000 if we're investing it at 4% compounded monthly? Okay, so on this problem, I know that because it says compounded monthly, that I'm using this formula. Because it said compounding monthly. Okay. So I need the principal investment, I need the account worth, I need the interest rate, and the N. I'm looking for how long is it going to take it to get to $10,000. Okay. So what is my principal? 8,000. What's my account worth when I'm done? 10,000. My interest rate, 0.04. And how many times is it compounding every year? 12. So we're putting those things into our problem. 1 plus 0.04 divided by 12 to the 12t. T is our variable. That's what we're trying to solve for. Okay? We're trying to get t by itself. So what's our first move to solve this equation? So t is in the exponential. So the exponential is this parentheses stuff. So I want to get that parentheses stuff by itself first. Okay? So I got to get rid of this 8,000. So how do I get rid of that 8,000? Divide it. So that's just going to be, what, 5 over 4 is what that'll reduce to be. Get it to do 5 over 4. Or 1.25, whichever way you want to put it there. And then over here we've got...
Do you have babies, Matt?
I do. All right. Now, this base is weird, right? It's not like a log base 5 that would cancel that out. So on this problem, I'm going to use natural logs instead of trying to get this number, because that's going to be a decimal that's got several places to it. So it's cleaner to go ahead and just solve it with natural logs. So I'm going to take the natural log of each side. That's going to allow me to bring the 12t down. Have a good weekend.
Thank you.
Yeah. Now, again, remember, I'm trying to solve for t. So what's going on between t and the 12? What math is happening between the 12 and the t? Multiplication. What's happened between the 12t and this natural log? It's out there in the front. We pulled the exponent down. It's not an exponent anymore. Now it's a multiplier. So this is 12t times natural log of that. So if I want to leave t there, all I got to do is undo this multiplication that's happening here with the 12 and the natural log. So I'm just going to divide by the natural log and the 12. So 12 natural log of 1 plus 0.04 divided by 12. All of that stuff over there is going to cancel out except for the t, which is what we want. Now I'm going to go to my calculator and I'm going to use the fraction button because it helps me organize it a little bit. Natural log of 5/4, 12, natural log of 1 plus 0.04 divided by 12.
Good morning, everyone. Happy Friday. Just a reminder, we will go to homeroom today during second block.
So 5.59
when the bell rings,
years.
will the following people meet me in my room for a very brief meeting? Lennon Gaddis, Presley Grames, and Leah Smith. And if you went with me on the FBLA trip this past week, your scores are available. Find me sometime during the day.
Practice day on Monday, that's 472. Those problems there don't get any, they're not really any different than these problems that we've worked here. You pay attention to what formula you should be using and work from there. Okay.